Hello viewers, welcome back to my channel. Today in this video I am discussing types of the matrices. Welcome to detailed course on linear algebra for IIT JAM and engineering mathematics GATE examination. This course is also useful for Csir net and as well as Kset mathematical sciences also. Now in types of square matrix, the first matrix is diagonal matrix. A square matrix in which all the elements except leading diagonal elements are zero is known as a diagonal matrix. A square matrix in which all the elements except leading diagonal elements are zero. Suppose we consider one matrix that is 1 0 0 0 2 0 0 0 3. We see this all the diagonal elements except diagonal line, all the entries are zero. With this type of matrix we call as a diagonal matrix. This type of matrix we call as diagonal matrix. Okay. Identity matrix also square matrix 1 0 0 0 0 0 1. This identity matrix also we call as a diagonal matrix. This identity matrix also called as diagonal matrix. Okay. Now we have to observe some observation, the important observation. We see some important observations. The number of principal diagonal line in square matrix is n. The number of principal diagonal line in square matrix is n. Suppose we consider a matrix, this is a11, in all the entries are 0 0 8 a22 and 0 0 a33 and so on n. This line in the diagonal number of principal diagonal line in square matrix is this is n. This is the diagonal matrix. Now, and minimal number of zeros in a diagonal matrix of order n is the minimum number of zeros in a diagonal matrix of order n, of the order n is n into n minus 1. Suppose we consider one matrix 1 0 0 0 2 3 0 0 1. This is the diagonal matrix, we know that, and this is the 3 by 3 matrix. Here order is 3, here n is 3. We see this in this matrix, how many zeros are there? 1 2 3 4 5 6 zeros is there na. Substitute this in this formula, 3 into 3 minus 1, 3 into 2, there was 6. That means the minimum number of zeros in the diagonal matrix of order 3 is 6. Order 3 is 6. This is the important. And multiplication of two diagonal matrices. I give the one short trick to multiply the two diagonal matrices. If we take matrix A of diagonal matrix A and diagonal matrix B, that is we written like this: diagonal of A1 A2 A3. We take 3 by 3 matrix and multiply it B1 B2 B3. Because why I am taking like this means, because except diagonal line all the leading entries are 0. That's why we directly take the like this diagonal entries multiply with another matrix diagonal entries. This gives a diagonal of A1 B1 A2 B2 A3 B3. This is the multiplication of two diagonal matrices. Okay, this is the square matrix. Now we have to learn what is super diagonal line and what is a subdiagonal line. Now we have to learn these things. See this is the square matrix, and we see this is the diagonal line. This is a diagonal line. Above the diagonal entries, these above the diagonal, these diagonals, these above the diagonal lines we called as a super diagonal line. Above the diagonal, this diagonal is called as principal diagonal line. Principal diagonal line, this diagonal we call as principal diagonal. These above the principal diagonal lines we called as a super diagonal line, and below the diagonal, this diagonal line we called as a subdiagonal line. Subdiagonal, below these uh, lines we called subdiagonal lines. Subdiagonal lines, and above these diagonal lines we called as super diagonal lines. Super diagonal lines. And we also observe one important thing is total number of elements in square matrix is n square. The number of elements in subdiagonal line of the square matrix is n minus 1. Okay, the number of elements in subdiagonal line of the square matrix is n minus 1, and total number of elements in the square matrix is n square, because we take one matrix 1 2 3 4, here 2 by 2 matrix. The number of elements in this matrix is this is order 2, that is 2 square, that is 4 elements in this matrix. And next type is scalar matrix. Scalar matrix, this is also a type of square matrix in the all the diagonal elements are equal. This is also a square matrix, in which all the diagonal elements are equal. This type of matrix we called as a square matrix, scalar matrix. This is scalar matrix, and for example we take A is 3 0 0 0 3 0 0 0 3. We see this in the diagonal entries. This in the matrix, all the diagonal entries are equal. All the diagonal elements are equal, and in this matrix, except leading diagonal entries, in remaining all the elements are 0. See this is also 0, this is also 0. In another definition of this scalar matrix is a diagonal matrix. This also square matrix, as well as this is diagonal matrix also. A diagonal matrix in which all the diagonal elements are equal. This type of matrix is called as scalar matrix. In diagonal matrix, all the diagonal elements are equal. That means A is equal to diagonal of 3 comma 3 comma 3. Okay, and unit matrix. What is unit matrix? The third type is unit matrix. A diagonal matrix in which all the diagonal elements are unity. Unity is known as a matrix or identity matrix. Suppose this matrix we called as a identity matrix. Unit matrix or unitary matrix or identity matrix. Identity matrix, that means a diagonal matrix in all the diagonal elements are equal, that is unity. That means 1 0 0 0 1 0 0 0 1. That means this also a diagonal matrix in which all the diagonal elements are equal to 1. That means see this, all the diagonal elements are 1 1 1 only. That means diagonal of this is 1 1 1. A is equal to diagonal of 1 1 1. If all the diagonal elements are 1 1 1, then this type of matrix we call as identity matrix or unit matrix. This matrix we also call as a scalar matrix. This matrix also called as diagonal matrix also. Okay, and we move on to another type, that is upper triangular matrix. Upper triangular matrix. What is upper triangular matrix? Means a square matrix is said to be upper triangular matrix in all the diagonal, below the diagonal elements are 0. Below the diagonal elements are 0. That means suppose we consider one matrix 1 2 3 0 4 5 0 0 2. See this in diagonal, this is a diagonal line. These below diagonal elements, all the below diagonal elements are 0. Below in the diagonal elements, the diagonal line, suppose see this, we take this as below the all the diagonal and below the all the diagonal line entries are 0. This type of matrix we call as upper triangular matrix. See this, we write down like this. Nah, the below diagonal line entries, all the entries we call 0. This type of matrix we called as upper triangular matrix. This form like this is in the form of like this. We return in the form of like this. Suppose we take another example, 2 by 2 matrix 2 0 3. This is also upper triangular matrix. See this, this is the form the triangular, and below this below the diagonal entries are 0. That's why this is also one of the upper triangular matrix. Okay, we take like this, we take any example 1 0 0 0 0 1 0 0 0 1. Okay, this is also upper triangular matrix. Identity matrix is also upper triangular matrix. Okay, identity matrix is also upper triangular matrix. Identity matrix is also upper triangular matrix. And move on to lower triangular matrix. Lower triangular matrix. What is lower triangular matrix? What is lower triangular matrix? A square matrix is said to be lower triangular matrix if the diagonal element or in the diagonal line above the diagonal line all the entries are 0. Above the diagonal line all the entries are 0. Suppose we consider one example 1 0 0 2 3 0 4 5 6. See this, this is diagonal line. Above these all the entries are 0. Above these all the entries are 0. That type of matrix we call as lower triangular matrix. This forms triangular this forms like this triangular form. That's why this called as a lower triangular matrix. This written like this also. Okay, these all the entries are 0. Above the diagonal line all the entries are 0. This type of matrix we call as lower triangular matrix. And we see this, we consider 1 0 0 0 1 0 0 0 1. This is the identity matrix now. See this, all the diagonal elements the diagonal line, above the diagonal line all the entries are 0. That's why this is called as lower triangular matrix. That means identity matrix is both upper triangular matrix as well as lower triangular matrix. Identity matrix is example for both upper triangular matrix as well as lower triangular matrix. Okay, this is the important note for diagonal matrices. The determinant of diagonal and upper triangular matrix and lower triangular matrix is equal to product of leading diagonal elements. That means we take one example 1 2 0 0 5 6 0 1 2. This is the, see this, what is the determinant of, sorry, this is also 0, this is 0. This is the diagonal matrix now. We called as this as a diagonal matrix. 1 0 0 0 5 0 0 0 2. This is a 3 by 3 diagonal matrix. So the determinant of this matrix is all the product of all the diagonal elements 1 into 5 into 2, that is 10. This is the answer of this question. Same we take one upper triangular matrix 2 1 0 0 2 0 0 3 0 0. See this, this is lower triangular matrix. This is lower triangular matrix. The determinant of this matrix is a product of all the leading entries of diagonal elements 1 into 0 into 0, that is determinant of this matrix is 0. And we consider one upper triangular matrix 1 2 3 0 3 2 0 5 0. This is we called as upper triangular matrix. The determinants of this matrix is a product of all the leading diagonal elements. That means the determinant of this matrix is 1 into 3 into 0. Therefore that determinant is equal to 0. This is the main important note for diagonal matrices. Thanks for watching. If you like this video, please like, share and subscribe my channel. In next video I am discussing symmetric and skew symmetric matrices. Thanks for watching.